Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Here we're told that the thickness of the plate is T, and it's 1 times 10 to the minus 2 meters, and each side has a length of 3 times 10 to the minus 2 meters, so the area of the square plate A is 3 times 10 to the minus 2 meters squared. Coefficient of friction is mu sub s, and it's 0.91. The mass is m, 7.2 times 10 to the minus 2. And the shear modulus, which we call S, is 2 times 10 to the 10 newtons per meter squared. For part A, it says determine the maximum amount of shear stress. So the maximum amount of shear stress, which I'm going to call tau, is equal to the force F divided by the area A. Well, we know what the area is, and the force here is mu sub S times m times g, since that's the force from the coefficient of friction, where g is just the acceleration due to gravity, divided by A. Plugging these values into this expression, we find that this is equal to 710 newtons per meter squared, which we can box in as the solution for A. Part B says find the maximum amount of shear strain. Okay, well, the maximum amount of shear strain is typically represented by delta L, the change in the amount of the length divided by the original length, L naught. And this is equal to tau divided by S. Or in other words, this is equal to the shear stress divided by the shear modulus. Plugging these values in, we find that this is equal to 3.6 times 10 to the minus 8. And it's unitless. So we can box, I fix that 8. There we go. So we can box that in as our solution for part B. And lastly, for part C, it says the maximum possible amount of shear deformation delta X. Okay, so to find delta X for C, oh, sorry, I indicated B as C, so this is B. There we go. For C is delta X is equal to delta L over L naught, the value that we found previously, multiplied by, in this case, the thickness of the material T. So plugging those values in, we find that this is equal to 3.6 times 10 to the minus 10 meters, which we can box in as the solution to our question.